Alright, Math 3, here we are with our homework, and it is graphing trig. Now, the main thing I want you to worry about is finding the amplitude, the period, and the midline. Okay? Now, I will graph these to help you understand how to graph them, since it wants one period, so that we can see how that works. Okay? So, first thing we should remember is when we talk about our sine and cosine, the standard form is like this. A times the sine or cosine of bx plus k. The A, that's our amplitude. B, you take that and put it under 2 pi and simplify, that becomes your period. And then K is your midline, how it shifts it. Okay? So, looking at question 1. It's like there's a 1 in front of sine, so it'd be our amplitude would be 1. Okay? There's no number for B, so our period, well, technically it's a 1, so our period would be 2 pi, because 2 pi over 1 is just 2 pi. And then our midline would be 2, because it's positive 2. Okay, well, how would we graph that? So let me go over here and just sketch out a graph, a rough graph, okay? Now, the way to think about this is, first I'll just graph sine functions, okay? And let me show you what the parent function looks like. So, a period on a parent function is 2 pi, okay? And we have about 5 points that we want to really focus on graphing. Okay? It also has an amplitude of 1 and negative 1. Okay? And actually, I should probably make those down a little lower. A little too low. We'll go right there. 1 and negative 1. So a parent function, okay, for sine starts out at 0, 0, because if we think of that unit circle, the y value at 0 degrees is 0. Then we go to 90, it's 1. We go to 180, it's 0. We go to 270, it's negative 1, and then back to 0. So we have 0, then 1 at pi over 2, or 90, then 0 at pi, and then at negative 1, down at 3 pi over 2, or 270, and then back to 2 pi. So with these 5 points, we can draw our parent function. Okay. Now for ours, we have an amplitude of 1, so that stays the same. Okay. Period of 2 pi, so that stays the same. A midline of 2. So what that's going to do is actually, it's just going to bump things up. So the midline is usually right about here. Okay, so it's going to move everything up by 2. So I start at 2, and then when I go to pi halves, I go to 3, up pi, and then at 3 pi halves, I'm going to go down 1 from that midline. So that midline is like right here. And then I'm essentially drawing the same graph because this one didn't end up being any different. And so here's one period of my new graph. Okay, that wasn't the best drawing, but oh wow, I'm having issues. Okay, but it looks something like that. All right, so number 2 is also a sine function, so let's do that one. We'll just deal with the sines first and then do cosines. So, amplitude of 1. My b is 1, so my period is 2 pi. And now my k, my midline shift, is negative 2. So essentially, I would draw that same graph, except this time we're going down 2 points for everyone. Okay? So that midline shifts down to negative 2. And then I start out at 0. Then I go up 1, back to 0, down 1, back to 0. and it's like that. Okay? So let's jump down to 5. Now 5 is going to throw us off because now we have an amplitude of 2. So that means instead of going up 1, they're going to go up a little higher. Okay? I also have a b at 1/2. So for my period, I go 2 pi divided by 1/2, which remember we can't have divide by a fraction, so we instead multiply by its reciprocal. So I get 4 pi. Okay? So my period is now 4 pi. And my k, my midline shift, is 1. So if I'm graphing this one, I actually am going beyond this, and I don't really have the space to do this, but let me draw another graph here to show you what I mean. Okay, so here's 2 pi. So 4 pi would be right here. 3 pi. Regular pi. Pi halves. 3 pi halves. 5 pi halves. And 7 pi halves. So once again, our midline normally starts at 0, and then we have up 1 and down 1. So then I'd go up here, down to here, down here. There's my parent function for our sine graph. Now for us, we have an amplitude of 2, period of 4 pi, and k. So here's how we think through this. So I've got these 5 points. Okay? Normally from start to finish, it's 2 pi. This time, however, I guess first we should probably deal with the midline. So normally midline is at the 0 axis. Our midline is up 1. Okay? So I shift everything up 1. And normally if I just shifted up 1, everything would just go up 1 and it would look something like that, right? But now I've got to think in terms of my start and my finish. Normally we start at 0, we're still going to do that. But instead of finishing at 2 pi, I finish over here at 4 pi. Notice start and finish are in the same place, okay, on the midline. Also, the one directly in the middle is in the same place. So what's half of 4 pi? It's 2 pi, so I have a middle piece right here. Okay? And usually we went 90 degrees, but because I'm doubling everything, I would go to 180 degrees, or pi, to go up. Now, not only am I going up at pi, I'm going to go up 2, because my amplitude is 2. So I'd go up right here. That also means down, I'm going to go down 2, so starting right here, I'd go down 1, 2, right there. So not far enough, is it? We'd go to 3 pi, because this point right here is going to be in between those two. So I'm going to go down here to -1, because that's 1, 2. And now here's my new graph. Okay, so first of all, what we should notice, this is twice as big as this. Okay, everything got shifted up 1 to start with, and I took this normal period and I stretched it out to that far. So this stretched up here, this stretched out here, this to that, and that to that. So it stretched it out as well. Okay? All right. Okay, number 7. Now we have a -1 for our amplitude. Our amplitude is still 1. That negative just tells us instead of starting out like this, we're going to start going down and then up. Okay? That's the only difference here. Then my period is pi. Not pi. My period is 2 pi divided by 2 pi, because b is pi, which those cancel, leaving me 2. I have a period of 2, and then there's no plus or minus, so my midline shift is still at 0. Okay, so if we were to graph that one, now this is where it gets weird, because my period was 2. Okay, pi is 3.14. Okay, so 3 would be a about right here. Okay? So pi over 2 is like 1.5. Okay, so it would look kind of like this for 1, 2, and 3. Okay? So 2 is where my period ends. Okay, now I didn't change my midline shift, so I'm not going up or down, so that's my end point. That's this point right here. And this is my beginning again. Now, my amplitude is 1, so I'm going just as high, but instead of starting to go up, I'm going to go down. Okay? Now, notice again, our start, our end, and our middle are on the midline. Our start and our end is on the midline, so is our middle. So we'd be at 1, would be our middle. Then because it's negative, we go down to -1, halfway in between, and up to +1 right there, and it would look like this. That's what one period would look like on that one. Alright, so kind of crazy, isn't it? Alright, so we've got 2 more to go here. Okay, so number 9, amplitude would be 4. Our period would be 2 pi divided by b, which is 2. 2's would cancel, we're left with pi. And our midline shift is down to -2. So, amplitude of 4 is going to really change things, right? So, that's normally 2 pi, pi halves, 3 pi halves. Okay, now normally here's our parent, 1. Okay, however, for us, we have a period of pi. So my start here at 0, end here at pi. However, our midline shift is also down 2. So I'm going to have to shift those down 2 for my start and my end. Okay. Then in the middle, it'll be at that midline still. Okay. Now my amplitude is 4. So when I go halfway between these two, okay, I have to also go up 4. So it'll be about right here. When I go halfway between these two, I'm going to go down 4. So it'll be like right there. So I end up going like this for my function. Okay, and our last one, right here, number 11 of the sines. Okay, amplitude of -1/2. Okay, so basically 1/2. The negative means it goes down first. A period, there's no number with the x, so it's just 2 pi. And k bumps us up 3. All right. Oops. So we bump up to 3. That's where we start. Our period is still 2 pi, so that's going to bump up to 3 as well. That'll bump up on the midline. Okay. Then, that's those two. Our amplitude is -1/2, so I'm going to start going down. And when I go to pi over 2, I'm only going to go halfway. And when I go up, I only go about halfway. So I end up with a graph that looks like something like that. Okay? And there we go with the sines. All right. Okay. Now let's just finish with sine altogether. So 13, 14, 15, and 16 are trying to write the amplitude, the period, all that stuff with these sines. So first thing we want to do is figure out our amplitude and our midline shift. Okay. Midline shift, we take how high it goes, how low it goes, we cut it in half, so right about here. Okay. So our midline shift is at -1. Okay, now our amplitude is going up 1, 2. So amplitude is 2. Okay, now we need to find our period. Okay, so period, we need to figure out, okay, so we're starting here at -2 pi. How long does it take me to get to the next one? Okay, so it takes me from -2 pi to pi. From -pi to 0, 0 to pi. Okay, so let's hone in on this spot right here. So that's a period of pi. Okay, so we need to figure out what our b is to make the equation. okay? Because the equation is a times sine of x of bx plus k. A is easy to replace, okay? It's 2. So f of x equals 2 times the sine of, not pi, okay? We have to go 2 pi divided by b is equal to r period. So if we multiply this out, essentially what you have to do to find b is to take whatever your number is and divide it. So 2 pi divided by pi would give us 2. Okay, so 2x, b is 2, and then my k is -1, so -1. And there's my new formula. Okay, that's all we have to do. All right, let's take a look here. Number 14. So how high does it go? How low? We find our midline right here at +1, so k equals 1. Amplitude 1, 2, 3. Period. We started right here. We end right here at 4 pi. So period is 4 pi. So my b would be 2 pi divided by 4 pi. Pi is canceled. 2 over 4 is 1/2. b 1/2, my equation. F of x equals 3 times the sine of 1/2 x plus 1. Okay, number 15. Top, bottom. There's my midline at 3. My amplitude is in 3 to 4, so that's 1. My period starts here, goes to here, so that's 6 pi for a period, which means to find b, I go 2 pi divided by 6 pi. Pi is canceled. 2 over 6 is 1/3, so b is 1/3. So I go f of x equals amplitude times the sine of b times x plus k. And there's number 15. Okay, so if you know what you're doing, obviously it looks really simple, but you know these numbers for the most part are pretty easy to figure out. Okay, number 16. Top and bottom, cut it in half. There's my midline at -2. Amplitude would then be 1. Okay. Now notice here on this one, and I guess I should have mentioned it on this one, it's going down then up. These ones start going up and down. This one should have had a negative out front. I can't remember if I put it. So this amplitude, kinda, you should think about it as being -1. Okay. Then a period, we start here, go here to 2. Okay. So my period is just 2. So b would be 2 pi divided by 2, which would just be pi. So my equation, f of x equals -1 times the sine of pi times x minus 2. And there we are with our sine functions, okay? So now let's take a look at our cosine functions. And let's deal with those guys. So let's start off, and let's actually talk about our parent graph for cosine. For cosine, okay, now it's the x values. Here is 1, so we start at 1. We go to pi halves, or 90 degrees, and that's 0. We go to 180, and that's -1. We go down to 270, or 3 pi halves, that's back to 0. And as we go back around to full circle, we're back up to 1. Okay, so it looks kind of like this for that parent function. And that's what we're going to base everything off. Just like with sine, we'll do it off that. So looking at this, so once again for amplitude, how high do we go? How low do we go? Find the middle. So we go 5 and 3, so the middle would be 1. So there's my midline, k equals 1. Okay, we go up 1, 2, 3, 4, so amplitude of 4. Okay, if we start up here, we go down and then back up. So that's a period of 8. Okay, so I go 2 pi divided by 8. That becomes pi over 4 when we simplify. So my b is pi over 4. So I would go f of x equals 4 times the cosine of pi over 4x plus 1. Okay, 18, same idea. Top and bottom, midline's at 0, so k equals 0. Amplitude is up or down 2. My period, starting up here, we go down and then back up. So my period is 2 pi thirds. This one's crazy. So for b, I go 2 pi divided by, and let's write it out differently. With fractions, sometimes it's easier to write it like this, because I know that's 2 pi times 3 over 2 pi. 2 pi's cancel, I'm left with 3. So b is 3. So f of x equals 2 times the cosine of 3x, and then plus 0, so I just leave it like that. Okay. Clear some space for ourselves. Okay, 19 and 20. So 19, high and low, so middle's right here at -3, k equals -3. My amplitude is 2. Okay, my period is, now notice here we're starting down low, so that amplitude's going to be negative. So to get back down there, we have our period of 2. So for b, it's just going to be pi, because 2 pi divided by 2 is just pi. So f of x equals -2 cosine of pi times x minus 3. Okay, number 20, high and low, so 3 is my midline. Amplitude would be 1. Once again, notice that we're starting down low, so that's like a -1. Then we go up and then down. That period is 2 pi, which means b is just 1, because 2 pi divided by 2 pi is just 1. So I have f of x equals -1 cosine of x plus 3. Okay? There we go with those ones. Pretty crazy, and yes, I can do it really fast, but that's because I've had practice. But it is that simple once you just keep practicing with it. Okay? All right. Now let's just look here and deal with the cosines. We'll graph as many as we can get through. Okay? So, amplitude would be 1. Period would be 2 pi, because b is 1. K would be 3. For amplitude of 1, period of 2 pi, k would be -3. Okay, 6, amplitude of 2, period would be 2 pi divided by 1/2. Well, it's like that 2 is going to end up there, so 4 pi, k would equal -1. 8, amplitude of -3, 2 pi divided by 2 pi is 1, so period of 1, and then a k of 0. 10, amplitude of 4, period of 2 pi divided by 2/3, that would be times 3/2, right? So 3 pi, k equals 3. Okay, and number 12, amplitude of 2, period of 2 pi, and a k of -4. Okay, so let's see what we can take a look at here. So we'll take a look at these three first, because they have the periods that are easier to deal with, okay, because they have that same period of 2 pi. So the first, we have an amplitude of 1, period of 2 pi, and a midline of 3. So that midline of 3 means we're going to shift everything up, that midline up to 3. And then we have an amplitude of 1. So we start up 1, okay? We're also going to end at 2 pi, up 1. Now halfway between up pi, we're going to go down 1 from that, and then at pi halves, and 3 pi halves, it'll be on that midline, and it'll look just like that. Okay? Basically just shifted everything up by 3, and the amplitude stayed the same. Okay, now if we look at this one right here, period of 2 pi, amplitude of 1, k of -3. So just like this one, except we're going to shift it down to -3 for our midline. Okay, but everything's the same way. We start our amplitude up 1, we end our amplitude up 1. In between those two, at pi, we go down 1. And then on the midline, we have those two. So it looks like that. Okay, so they're essentially parallel to each other, just shifted slightly. And that's that one. And then finally, we're going to shift it down 4 and have an amplitude of 2. So if our midline is down at 4, we're going to run out of space, aren't we? And an amplitude of 2 means we'd start here at the same place, end at the same place. That would be shifted, and we'd be clear down there. That'd actually be further down, and it would look something like that. Okay? Now these other ones, we have different periods. Okay, let's take a look at these two first. Okay, so a period of 4 pi means that we're just going twice as long, right? And has an amplitude of 2 and a midline of -1. So we're going to shift our midline down 1. So notice that these 2 points are always on the midline, okay? So we're going to have to find where they fit. Now our amplitude means we go up 2, so we're going to start up at 2. We're going to end at 4 pi, instead of just 2 pi, we end up at 2. Okay, and halfway in between that, which half of 4 pi would be 2 pi, from that midline we're going down 2. Okay? And then halfway between those, so at pi and at 3 pi, is where we hit our midline. So it looked like that. So we've pulled it this way with the amplitude, we've stretched it out this way with our period, and then we just shifted all of it down 1. Okay? Alright, now, that was this one. Now this one here, we've got a period of 3 pi, an amplitude of 4, and a k of 3. So k of 3, amplitude of, 4, I thought it was 4, and a period of 3 pi. So we're going to bump it up 3 for our midline. Okay. Then we're starting 4 above that. So we start up here. We also end our period at 3 pi up there. Okay. So now we kind of want to just, with 3 pi it's hard to cut in half, okay, because it'd be 3 pi halves would be, so right here would be our halfway point, and we'd go down 4. So right about there, okay. Then we just kind of estimate halfway between, and draw our graph, okay, and it would look something like that. Alright, now the last one is the weird one where we no longer have a pi for our period. So with that period of 1, okay, remember, pi halves is like 1.5. So it would be, 1 would be right about here, okay? So then 0.5, 0.25, 7.75, those are kind of the numbers. So an amplitude of -3, k of 0. So our midline, so we start, amplitude was -3, so we start going down. So we have to go down to -2. It's where we would start. Okay. It's also where we would end at 1. And then we would go, oh wait, I didn't go down far enough, did I? It's at -3. Hold on. Here we go. So we start here at -3. It's also where we're going to end right there. Okay. From here, we're going up 3. So in the middle, we'd go up 3. And then we'd hit the midline about like that. So it'd look really crappy drawing, but it looks something like that. Alright guys, so there we go. We've dealt with everything on this one. So some pretty good stuff. There we go.